Colby, 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 math.com.
In class, we've been calculating circumference and circular area. Problems 1, 2, and 3 on this assignment ask you to calculate rough estimates of circumference, so make sure you read those directions and make it easy on yourself by approximating pi as 3 rather than 3.14. If you don't follow those directions, you're just doing extra work on those first three. Problem number 4 says a square and circle drawn in the same plane can intersect in at most how many points? Well, your piece of paper is a representation of a portion of a plane, and so if you try to draw a circle and a square on your piece of paper, you can look at different ways that that circle and square can intersect and see if you can find the most possible intersections you can draw by drawing a circle and a square intersecting each other on your paper. Problem number 6 says the ends of the track shown are semicircles. A semicircle is half of a circle. Exactly how much farther would you run in 10 laps in the center of lane B than if you ran in the center of lane A? And so in order to solve this problem, the first thing you need to recognize is that these straight sections of the track are 98 meters, whether you're in lane A or lane B. And so those sections of the track can be disregarded when you're finding the difference in the distance run by each runner. However, the circular portions of the track are certainly different. If you're in lane A and you're running in the center of that lane, you run this distance, while the runner in lane B would be running this distance, which is, it's hard to draw this, but which is clearly a greater distance. When runners are actually running in events like this and they're assigned a lane, let's say this is the starting line, they start the runner in lane A back some distance to make up for the difference in the distance run for however many laps they're running, so that it's a fair race. But if you take your paper, I hope this shows up, if you take your paper and you fold your paper this way, and then you fold it again, it's possible to fold it so that you can see the circular parts of the track. The two semicircles can come together to form full circles. And so really the difference in the distance run is just the difference in the circumference of those circles. And we're given this distance as 19 meters. So that'd be the radius of the circle for lane A, and the radius for the circle for lane B is 20 meters. So with all that understanding, why don't you, during the pause, see if you can answer this question, and then come back and see how you did.
Paused.
The difference in, first let's start with the formula for circumference. Circumference is exactly equal to pi multiplied by the diameter. Oh, I forgot something pretty important, but hopefully you picked up on it. If you used 3 or 3.14, you calculated the approximate difference. But because it says exactly how much farther, we're just going to keep pi as pi. It makes things a lot simpler, actually. But I'll tell you what you would get if you had used 3.14 before we finish. And then I'm going to use some subscript notation to differentiate between lane B and lane A. The circumference when you're running in lane B would be pi multiplied by the diameter for lane B, and then you just have to recognize that this 20 is the radius, so the diameter would be 40. And the circumference for lane A would be pi multiplied by the diameter for lane A, which would be 19 doubled, so 38. Because they're asking how much further you'd run in 10 laps, 10 times the circumference of the circle for the runner in lane B would be equal to 10 multiplied by 40 pi, and 10 multiplied by the distance run by the circumference for the runner in lane A would be 10 multiplied by 38 pi. And so the difference would be 10CB minus 10CA, which would be 10 times 40, 400 pi, minus 38 times 10 is 380 pi. And so the difference, the exact difference in the distances run would be 20 pi meters. If you use 3.14, it's just going to be 3.14 doubled to 6.28. So you would have gotten 62.8 meters as an approximation, but of course that wouldn't be exact. So go ahead and change your answer to this if you now understand that the only way to get an exact value is to keep pi as pi, because it's irrational. No decimal representation, however long you make it, would ever be exact. Only the simple pi is the exact value for pi. I hope that helped with this problem. Thank you for watching the video. I'll see you tomorrow.